In this video we'll show you how we can import a DXF file into PartMaster CAD, set the datum, create the contours required for machining, and then go through to the machining module. Okay, so this is the drawing that's been imported into the CAD system. Now often with DXF files the datum position is not where you want it to be, so we might need to reset the datum. Okay, so the way that we do that is we go into NC mode, and then from the vertical toolbar here we choose datum, and the snap mode is set to near snap, so the snap here can be onto the center of this circle here. So that sets up the datum, and now we can create these contours that we need for machining. So to do that we go into contour mode, and then we'll start off with these inside contours here. Okay, now if you look at the end view here, you can see how the shapes will need to have different Z depths and different origins in Z, so that we're not machining in fresh air too much. Okay, so if we're going to do that, let's do this rectangle first, and we'll set that to be at Z0, and the depth is whatever depth it needs to be. Okay, so that's created a contour of that shape, which I'm going to use that as an area clearance to cut down to the center web. So now we'll do these contours here. Now in this case we'll have the Z surface as -5mm, because it will be below the Z surface there, so that we're not having to machine fresh air at feed rate down to that surface there, and then the depth is the depth from there. Okay, that's that contour done, and now the same parameters for this contour here. Okay, now we can do the end bores here, and that will have a Z surface of 0, and a depth, if we go down to the center line, we'll go down to 10mm. Okay, that's done that one. This one here, that will go down to 5mm, and the same here. This one, that will go down to 5mm, and this one here will go down to 10mm. Okay, and then the outside one, if I start off about there, and that will also go down to say -12.5, so we go down past the center line. Right, so that's created all the contours for us. Now the nice thing about this is doing it in the CAD system is that we can control exactly where the start points are of all these contours. So if we save this drawing away, I'll save it into my drawings folder, and we'll leave that same name as the DXF file had, and then we take that through into machining. Okay, so the first thing to do when you get into machining is you see the setup dialog box here, so you need to check on the tool change position, make sure that there's no anomalies here. One thing that you can have, of course, is you can have the tool change position as XY0, but you don't want the tool change position to be Z0, because that's the top of the job, so you would not want the tool to be going and rapiding to the top of the job. Okay, so let's define our tools. So let's define the first tool and say that's a 20mm tool. Now because it's got a radius on the end, and we need to machine that, we'll give that radius, we'll set the depth, the length of the tool, and the cut depth. Okay, so that's defined the tool. Now we need to select it for use, so we do an M6. This is where we set the spindle speed and the feed rates. The feed rates can be in feed per minute or feed per rev, and we have a principal feed rate here, which is in this case would be in the XY plane, and a Z-axis feed rate, which is in the Z-axis. If we want the coolant to be switched on, we switch it on here. So that's set up that tool, and now we can machine out that rectangle. So to do that we just use the area clear. Now we've got a list of contours here, but I don't really need to worry about the names of them because I can just choose them with the cursor. So I choose that and highlight it. Okay. Now you can see how it picks up the work surface and depth from the CAD drawing. If we've gone onto the options tab, here we can set the style of machining. So for a simple rectangular shape we'll have contour machining. If we wanted to, we could machine out from the center, but in this case we'll leave all the defaults as they are. Okay, and then if we just switch on the tool center line and run that, then that just runs through there. Okay, so that's machined that out. Now obviously you're going to get corner radii here which match the size of the tool. Okay, so that's machined out the first part. Now when we're creating a program using the CAM system, all the operations are listed here in the program operations window. So the good thing, or the way to really do it, is to switch once an operation is completing and we're happy with it, to switch it off so that we don't see multiple tool paths all over the screen. So the next thing we'll do is we'll define the next tool. So say we'll have a 10mm cutter, and again we set the length and the cut depth. The cut depth is specified by this line here, and that will determine the amount of cutting that it's allowed to do in the Z axis. So if we had a cut depth of 3mm and a contour which was 10, it would slice it into a series of Z level passes. But in this case it's fairly shallow, so we probably don't need to do that. Pardon me. So the next thing is we'll do these two center slots here, and again we'll use an area clear operation on that one first, and one of the options I'll choose now is to machine out from the center. Okay, now we can do another same operation on that one there, machine out from center. Okay, so that's done those two. Now we can probably use that same tool to do the other ones here. So again, area clear, this one there, machine out from center. One of the other things that we could do is we could specify a ramping option so that we can ramp down at an angle, or if we want to do helical milling into there, we would specify that as spiral drilling. Okay, so that's done that one. Now we do exactly the same thing on that one there, and machine out from center. Okay, if we switch on the tool envelope and run it, we can see those four shapes have been machined. Okay, so again, because we don't want to see those each time, we just switch them off. Now we might need to use the same tool or a different tool to machine the end bosses here. We'll use the same tool, but if we needed to, we could just simply specify a different tool. So we'll stay using the same tool, but this time we'll use the option which is called the go round, which is for contour machining. So again, we pick the contour that we want, and then from here we can specify an approach or a runoff. So this is how it's going to approach the start point of the circle, and the approaches can either be switched on or off. And then if you switch it on, the options are normal, which is a straight line approach, arc, which gives you a line and tangent, parallel, which gives you direction of parallel to the direction of travel, and a rectangular, which puts two linear spans before the arc radius on. So in this case we might as well start with an arc span, and let's have a distance of just slightly bigger than the tool radius, 6mm, and the same thing with the runoff, 6mm. Okay, so that machine's round there, and now we can do the same thing for the bottom one. But the other thing that we can do is, if we've set up a lot of parameters for one particular operation, then what's sometimes useful is to be able to highlight the operation in the Program Ops window here, right click and say copy, right click and then say paste. So we've got two operations there which have all the parameters set up, but obviously they're working on the same contour, so we simply edit this one and tell it to work on a different contour, and then when we run that, okay, so we've got that set up, and now we can machine around the outside. So in this case we'll use a different tool. We'll use a 12mm tool, set up the length and the cut depth, that's fine. Select that tool for use, set the spindle speed and feed rate, and again we'll use a go round command on that outside contour there. The approach and run off, again they can stay as arc. Okay, so that's machined all of that, and if we switch on all of those operations now and we went into the ISO view, we could see the different depths. If we go into the split views, then we click into one window, and again we can see all the depths there. If we click into this window, okay, and so on. So depending on how you like to see the graphics, then you can switch on that split window as you need to. So before we post-process this, what we'll do is we'll run the simulator. So we call up the simulator. The type of machine tool is it that we've got? We've got standard vertical mill. So then we get the simulator dialog box. I'll just drag that into view so that we can see it. It calculates the maximum and minimum stock values for us, so we don't need to do much else apart from simulate it. Okay, so again what I'll do here is I'll just drag the window so that you can see that better, so you can see it more clearly. There we are. Okay, so that's the machine tool simulator. Now when we're running the simulator we can view just the tool path, or we can show just the material, or we can see the complete machine with the doors and the controller and everything. So if we're happy with that, we get it where we want the view, and then from the top here we've got a slider which controls the speed of the animation, and then we can run it. So here comes the first tool. There we are. So when that's finished we can zoom in, we can rotate the graphics around. If at any time we don't want to see the machine housing, we can simply hide it here, so that when we're looking we're not seeing the rest of the machine housing there. Now obviously when we're machining this we'd need to do one operation on the one side, turn the material over and do the same machining on the opposite side. Okay, so that's how we've done that job.